Hello, I'm David Shin, and this is Physics 2212, Lab 4, Bar Magnets. So, the purpose of this lab was to test magnetic field strength of bar angles at various distances. We used a phone to measure distance and observed magnetic fields from different angles. We used GlowScript as a computational model as well, and used it to generate a model and compare it with our real-world results. The calculated magnetic dipole moment was 0.841 angstroms per meter squared. The simulated magnetic field for an off-axis measurement was 19.6 microtesla, and the experimental had a magnitude of 72.4 microtesla. By observing magnetic field from different angles and distances, we found the magnetic field magnitude on our phone, and then measured the distance from the bar magnet. So basically, we found the chip location on our phone, as it was different per phone. We aligned the bar magnetic with a field with a chip on it. We aligned the bar magnetic field with a chip on the on-axis or the perpendicular direction. We measured for increments between 20 to 220 microtesla. And we also measured off-axis magnetic field with different angles. So here are some general equations we used. We used general magnetic dipole concepts, and we modeled the bar magnet as a magnetic dipole. We see here that the parallel magnetic field equation is on axis with the radius much greater than the distance between the dipole. This is the perpendicular magnetic field, which is slightly different. And this is also an equation for the vector equation of the magnetic field. These are both magnitudes, and this is the vector magnetic field. So here's our data collection. As you can see, from different distances, you can see that the magnetic field is somewhat decreasing. You can see that the stronger the magnetic field is, the smaller the distance is. So this is the distance here. You see that at a magnetic field of 20 microtesla, the distance is 2.2 times 10 to the negative 1 meters, but as you can see, it's much closer here, as it's 9 times 10 to the negative 2. And we also have an LN linear regression model, as you can see here in the graph. It is pretty linear. You can also see that this is the corrected by the Earth's magnetic field, and we have an off-axis field calculations per the magnetic field. Here are the average values, and here are the LN values to model it on this graph. These are all on-axis versus the off-axis fields. So as I said earlier, we use an LN linear regression to calculate results, and we use this equation below to solve for the magnetic dipole moment on the axis, which is found to be about 0.8 angstrom meters squared. And you can see in our data here that the off-axis field, you can see that the distance is a lot greater for the off-axis field. But for this one, we also use the BY of the Earth to calculate for the discrepancy, which could make this a bit more realistic than these values from earlier, as we find the net B field here as well. So here is our GlowScript calculation. So you can see that we're setting these up. We're setting the distance away from the origin. We're setting up the magnet here. We have the magnetic magnitude. And then we have different arrows. So this is just generally setting up the magnet. And then we're also setting up the dipole B equation. See that here is the way the magnetic field arrows are pointing. You can see that this is for different arrows, different bar magnets at different locations. So you can see that here in the red arrows, it's on the axis, and the blue arrows, it's pointing this way. And you can see that at a lot of these different points, the magnetic field is pointing in all sorts of different directions based on how it moves with the magnetic dipole. So, an error discussion from before, there is probably a lot of interesting inconsistency due to the phone chip. The phone chip is probably not the most accurate tool. There are probably many more other accurate tools to measure magnetic field. There are other interfering magnetic fields, and the chip could be overly sensitive. As you can see here, the simulated magnetic field was 19.6 microtesla versus the experimental of 72.4 microtesla. You can see that's a large discrepancy. This could be due to these errors here shown below. And finally, for what if we hadn't oriented the phone properly, the Earth's magnetic field would affect both X and Y measurements instead of just the X measurements, and that would make data collection pretty inconsistent, as we'd have to subtract from the affected Earth's magnetic field from other magnetic field measurements. Thank you.